All right, so here we are today to do a webinar, and what we're going to be doing is a walkthrough and demonstration of CNC Cookbook's GWizard editor and simulator. You can use the chat to ask questions. I'll keep an eye on it, and I'll try to stop certainly at all the major sections of the demonstration to go over any open questions and try to get them answered. But there'll also be time at the end to get your questions in. So if you think of something, just go ahead and key it in the chat, and we'll try to see if we can get it answered. Can everybody see the screen area with our World War II lady machinist here? She's working on doing some precision work. And this is from the GWizard Editor homepage. If you haven't already, there's a free 30-day trial available that's real easy. You just download the product. The way you find all of our software is you just click on the software menu that's at the top of our any page in the CNC Cookbook website, and you'll be able to see all the different software that we offer. I've got editor and simulator. We've got GWizard calculator. We've got a few other products too that are available that are pretty cool. For example, we resell Art Fennerty's Gearotic gear design software. Really neat software. It's a specialized CAD CAM for doing gear design. Really cool. Conversational CNC is something we're going to show off today. It's not a separate product. It's actually part of GWizard Editor. Very cool. We have a super simple CAM program that's ideal for beginners called Mesh CAM, and that's what we offer. So today we're here to talk about the G-code editor, though. So I want to start with the question of why would you need a G-code editor simulator? What are they good for? And it's pretty simple. Different people use them for different things, but the most common uses I'll run through. Number one is to check your CAM software's posted G-code in order to save time. Basically, if you can find problems and fix them while you're sitting there at the CAM program rather than at the machine, it's better. You're going to save yourself some time. You might save yourself some heartache in terms of machine collisions and that sort of thing. And so it's just a really good idea. A lot of different shops make it a requirement that you run a simulation before you run the G-code on the actual machine. So I know somebody's probably thinking, hey, my CAM program has a simulator built into it. What do I need this thing for? I always do a simulation before I run it on the machine. And the answer is CAM software, for the most part, uses a simulator that doesn't work from your G-code. What it works from is the geometry, the model that's inside the CAM software. And that's better than nothing for sure, but it doesn't reflect what's actually going to wind up being on your machine. And so if there's any problem at all with how the post works, if there's bugs in the CAM software, you're just not going to see that if you run strictly the CAM simulator. You can get the program over to the machine only to discover there's some things going on that didn't show up under your CAM software simulator. I knew a guy one time, for example, that was running one of the major CAM packages, and he loved it. He had no problem with it whatsoever, but he was so happy to be able to run a quick simulation because every so often this particular program, when he used work offsets and multiple parts in the same program, when he went to go to the second work offset, the first part always worked just fine. The second part, every now and again, maybe 1 in 6 or 8 G-code programs, it would just fire off a random rapids move back to someplace where the first work offset was. Well, obviously this is going to be a very unhappy thing. And so he would just run the simulator, spot that immediately, and it was just a simple matter to edit the code to delete that random move that was getting put in there. It was a bug in the CAM software, and it had been there for years. They couldn't figure out why it did it, but this was this guy's answer to deal with it. Another reason to have a G-code editor is to modify your CAM-generated G-code. There's any number of ways to go in there and do things to the G-code that maybe are helpful to you. Maybe it's expensive to have your post updated to do some of these things. Maybe you need to have code changed to work on a machine maybe with an earlier version of the control than what's on most of your machines. Maybe you just want to go in and make the code more efficient. A lot of shops do that. If they've got G-code that's going to be run over and over again on thousands of parts, you'd be surprised at how much faster you can make that code run by fiddling around with it in the G-code editor. There are definitely people that want to write G-code from scratch. I find this is particularly true in the turning world, where the programs are actually pretty simple to write. A lot of folks don't feel like the cost of CAM there is necessarily justified for simple lathe parts. But even if you're doing mill work, particularly with the conversational CNC wizards, you may find that it's really easy to generate up something simple. One guy referred to it as he liked to hand program fixtures. They're quick and easy. Most things are laid out on a rectangular grid. You know, maybe he needs to drill a bunch of threaded holes for, you know, mounting Mighty Bite clamps or something. But it's just really straightforward. It was faster for him to crank that code out by hand than it was to have to do a CAD drawing and run that all the way through his CAM software, so on and so forth. And then the last thing, and we get a ton of people. I've got students in vocational programs and mechanical engineering programs at all sorts of schools and universities that love it as a learning tool. I'm going to show you some of the features that make it easy for you to load up a G-code program into GWizard Editor and very quickly understand what that G-code is doing, even if you're not a G-code expert. So that's why you might want to have a G-code editor and simulator. Now let's take a look at it. Here is GWizard Editor, and I'm just going to resize this so I've got the whole thing in here. This is the product, GWizard G-code editor, and let me just do a quick tour of the different areas of the screen. So, you know, very familiar. You got pull-down menus that, you know, open up and do all the normal stuff. You've got a login bar. This is common to all of our products, and it's got some helpful things. If you click Getting Started, it'll take you to a page. It's got all kinds of stuff, you know, sample G-code, things of this nature. Tells you what version you're on, and this notice will change. If there's a newer version available, you'll get a button to install the new version here. By the way, we're running an unreleased version here. I wanted to show off a feature or two that are just about to go out, so it may be a little bit unstable, and that's no biggie. If it crashes, we'll just restart it. But this is an unreleased version, so because as I say, I wanted to show off a few things we haven't released yet. You can give us feedback anytime you like. Just click the button and you know, give us kind of your rating, 1 to 4. You know, is this helping you to do your work? Well, gee, we hope we don't get very many not very wells, but you know, please tell us if that's a problem. You know, I could use this, or wow, this thing rocks. It's really saving me a lot of time. And then tell us a little bit more about a feature we could add or a problem we could fix that's important to you and that's driving your opinion about it. These are the various customer support options. You can go to our user club. These are forums for users, and I frequent them to answer questions. Here's our support portal. You can go there and file a trouble ticket. You can go through our FAQs. You can also suggest and vote on as a group the different features you think we should add to our products. Here's help. And lastly, we'll pop up tips for you that, you know, this will come up automatically when you first get the product. You can tell it to quit showing these if you like, or, you know, anytime you want, you can come over here and click this little light bulb that says tip in it, and it'll give you some tips. Now, I just want to quickly point out on the website, you've got this help here. Right, and this is our help desk page, and it's got all sorts of different resources here for you to help you with the products. Here's your downloads, your registration forms, your troubleshooting guide for installing, getting started pages for the products, the user club. It's all here to help you out with what's going on. So be sure to take advantage of all the different facilities that we provided. Okay, let's get back to our tour here. So that's the login bar. We've got a couple of toolbars here, and you got your basic functions that are kind of common to all software applications. You know, loading, saving, clipboard, undo, redo. You've got a find, replace, jump to, and we'll go through these commands. Revisions, we'll go through those two. Those are high-powered commands for doing various transformations on the software. Let's see. Got a couple of questions here that I want to look at. All right, first question. Does the user need to be connected to the internet? Not necessarily. You will eventually have to connect to the internet. Basically, the way the software works is you need to be connected when you install and when you first log in, and then you have to connect again once every 4 weeks. And the software will tell you a few days before it's time to connect. Every time you use it, it'll try to connect, and so it'll try to keep that count of when it needs to connect as up to date as possible. And so, if, for example, if you're in a shop that doesn't have an internet connection, the best thing to do is put the software on a laptop, use it for 4 weeks, and then when it starts complaining it needs to connect, take your laptop with you, get a cup of coffee at Starbucks or wherever you got an internet connection, and you can go from there. Okay, let's get back to our tour here. Setup, and I'm going to go into some detail on setup. These are commands, we call them code wizards and conversational wizards that help you insert new G-codes into your program. There's a lot of them. They're cryptic. They're hard to remember, and this is all about simplifying that. And again, we'll demonstrate that in a minute. This little area right here to the right, this is the G-code simulator. I like to think of it as a debugger to help you find problems in your code. This is the G-code editing area, and there are more tabs here. We'll go through this to show you what's going on with those tabs. This is the backplot area. We'll show you what your toolpath looks like, and there's different views you can bring up. See it from different perspectives, and these are controls to manipulate the backplot. This area here is called the hint area, and we'll have more to say about that in a minute. But hints basically tell you what the G-code is going to do in plain English, which is to help you to understand what your program is doing. And then we have the status bar, which has a variety of information. You can see it's updating my XYZ position of my cursor. It tells me something. It tells me which post I've got, Fanuc Mill. It'll show me the DOS file name. A lot of controllers use a pure DOS style file name. And so I had somebody ask me, could I show the DOS file name, because the Windows file names get corrupted quite a bit in order to see that. And in fact, let me just load up a file with a really long name. So you can see home switch rear panel engrave would look like this in DOS. It's got 764 lines of G-code. Takes a little bit less than 22K bytes of storage. And you can see here's the G-code here. Here's what it looks like backplotted. And here's a hint, which is telling you this very first line here with the %. That's a full line comment. All right, I had another question, which is the wizard available on all Fanuc machines? Yeah, we do support Fanuc as one of our controllers. In fact, that's sort of the native G-code dialect for GWizard, and I want to talk about that more right now. So let's start off. You first get the software, you get it installed, and the first thing you're going to want to do is bring up the setup screen in order to get this adjusted for your particular machine. And so you got things you can do. You can set, imperial versus metric. And it's important to understand that in a G-code situation, there are a lot of different things that may be imperial versus metric. This is setting the grid and control panel units. So the grid is, these lines, right? And control panel are some of these indications here. But it's not setting the unit system for your actual G-code program. That's done with G-codes. And so because of that, you're able to run metric programs on CNC machines that are set up imperial and vice versa. It's a good thing, but it is a little bit confusing. You have the ability to create different machine profiles, and we need you to do that. We need you to tell us what are the capabilities of your machine. I've got one here I'm calling VMC2. It's a mill. I've got a make and a model. I tell it what the spindle taper looks like. I've got some spindle min-max RPM information, spindle horsepower. There's a power adjustment curve. What's the time to accelerate the spindle from 0 to its maximum RPM? We use this kind of information to help make our time estimates, because we'll tell you for each line of code how long does it take the program to get there and what's the overall runtime of the code. We have to use things like this to help us understand for your particular machine how long should we wait for the spindle to accelerate to the commanded speed. Maximum feeds and feed rates, both rapids and cutting feeds, GO1, GO2, GO3 happen at these feed rates that are set by the F in G-code, whereas G00 is this feed rate here. What are your machine's travels? Its acceleration, lots of different information here. There's tool changer information. What's your tool change to chip time here? It's 5 seconds. We have 24 tool changer slots. Yada yada. What are my coolant options? And right here, very important. This is the next thing you've got to do, is where you set which controller you're going to try to simulate. There's an old joke about the wonderful thing about standards is there's so many to choose from. And that's true of G-code especially. There are literally hundreds, if not thousands, of different dialects of G-code. There is no one dialect of G-code. And, there's machines that claim they run ISO G-code, for example. And I've seen all kinds of differences between those machines. Even though there's an ISO standard, the machine itself kind of is, well, we're pretty close to ISO, so let's call this ISO, or the RS standard in the U.S. is another one that's similar to ISO, and a lot of companies will claim their G-code runs that. The real story is there are a lot of different dialects of G-code, and you want to try to get close to that. And the way we do that is we select a controller, which I'm calling this a post, just for familiarity. Everybody with a piece of CAM software knows what a post is in the CAM software. In fact, I have a lot of people ask me, can I load my CAM software's post into GWizard Editor? And unfortunately, no. Posts are even less standard than G-code. And for the most part, you cannot exchange posts with any software except whatever it came with. So you have to do your own posts here. We have a bunch of them, though, to choose from, and you download the latest controllers from the web. We'll bring any new ones that we've created down and any updates to the old ones. You can browse a list of our posts, and we have a bunch of them. Bridgeport DX32, Centroids, FANUC, Haas. Haas is mostly FANUC, but they've added some cool features to it. Heidenhain ISO, plain vanilla ISO, Linux CNC Mach 3 for the hobbyist crowd. The little Roland mills use an interesting little dialect. So those are our canned posts, and we add more to this all the time. And in fact, that's really the purpose of this button right here. This is a new thing that's not released yet, but will be in the very next release, you'll have the ability to click here, and it'll take you to our post customization page here, right? Give you that link, and from that page, let me just show you what's going on there. So you've got information on how to customize the posts, which is good, but you've also basically got a ability to go to our editor post survey and request a new post. So if we bring up that survey, what's going to show us is, you know, these are the posts I've had requested from various people, and so we haven't released them yet. We're working on actually all of these, but you have the ability to add your vote to it, or tell us, hey, I need something completely different. I need the ACME Wile E. Coyote CNC machine post, or whatever it may be. Or the other thing is, you may not need a whole new post. So many of these controls have a lot of different versions, and maybe there's some G code or M code that's missing that you'd like to see added. And then the last thing, and this is very helpful, is if you're able to provide sample G code and a PDF programming manual for your control, by all means give us your email address. Nobody else will be able to see this, but I'll send you back email to get that information, because it'll help me to go about creating new posts. So that's the weird and wonderful world of posts. Now I'm going to delve into this a little bit further and show you how you can go about customizing your posts. Okay, so we'll click the Post tab, and the post is, for the most part, a series of different questions. Does your particular controller allow helical interpretation or not? What do you want the endpoint tolerance to be before we issue a warning telling you your endpoints are different distance from the center? So different, are you an incremental IJ or absolute IJK on arcs? These are all the different types of questions and flexibility we have into the post, and you can change these things. Does your control have a Fanic macro B style go-to? Some controls let you substitute a colon for the O when you're identifying subprograms. So that's what this is all about. Answer these questions. The second thing you can do to customize a post is you can change how the numbers are handled and what gives a warning. For example, some of you have probably worked on machines where you have to have a decimal point, whether there's going to be anything after it or not, on every coordinate. And so, once you learn that habit, you just always type that in. Well, you can provide that kind of thing, decimal required if you need that syntax, and you can do it for the different letters. They call them words and addresses in your particular G-code dialect. So that's another level of customization. Here's your macro variables, and most of them don't have any values at the moment, but you can go through and it'll tell you, okay, pound 863 is a non-volatile common variable, so it's there for your use. It'll be saved across G-code programs, yada yada. This is where you can customize all that stuff. Here's your G&M codes. You can do several things. So let's take this imaginary axis designation. If I double click it, I get the editing capability. I can set it to be enabled. I can disable it. I can say ignore it. I mean, there's a lot of G codes that you may encounter, and if we hit one we don't understand, we'll flag it as an error, but it may not matter for the simulation. Turning the chip conveyor on and off, who really cares for the simulation? So the easiest way to add those G codes is just to add them, mark them ignore, give a hint that says chip conveyor on, chip conveyor off, and now you're going to be able to simulate that program, and everything's going to come off looking great. The last thing you can do is you can create a macro, and it's a G-code macro that simulates whatever your new G-code is going to be. So for example, say you've got a CAN cycle, a fancy drilling cycle or something that's a little bit different. You can create a macro that simulates that for your particular control. So you have a lot of facilities available to add new G and M codes. And that link I showed you before for customizing posts tells you how to do that. Last tool for posts is kind of a sneaky thing. I call it the mapper. What it lets you do is basically search and replace things on the G-code line before they're executed. So let's say you got a machine that's almost the same thing as FANUC. You know, maybe it uses a P word instead of an L word or some crazy thing like that. Well, it's pretty easy to put a search and replace rule in to change the L's to P's, and thereby be able to run that on one of our existing posts. Okay, so that's how you go about customizing posts. So, Carl writes, I worked in a company that has 5 or 6 Mazaks, and the programmer's favorite line is that the Mazaks are the snowflakes of CNC machines. No two are alike. It's so true. I mean, there's so many G-code dialects, little things. Even if you've got FANUC, the machine manufacturer has a lot of different options that they can change in terms of how that FANUC control is set up, and they all want to add their little special touches. So it's good to be able to change your post. Now let me just finish out what's under the Setup tab, just so you know what's here. This lists all the different errors who have been disabled. So you have the ability to go into any error, and GWizard is set up to be verbose. We want to try to find alarm conditions before you get to the CNC machine, and so we'll look for things like, well, he did a GO1 before he got the spindle spinning, or before there was a tool selected, and this is where you go to turn that stuff off if you don't want to hear from the message. There's a tool crib capability here, and I was asked, can I share tool cribs? Yeah, you can. You can import and export from GWizard Calculator, export from Calculator, import them in here in order to get the tool crib that you want. We also have the ability to generate a tool crib from the G-code program, and I'll talk more about that in a minute, but that's also really handy. One of the things that happens to people that they may come looking for a GWizard editor for is, maybe you've been running some crazy G-code program forever. The guy that wrote it is no longer with the shop. You don't even really have any documentation. The CAM and the CAD is long ago lost. And you need to know what the heck is going on with this G-code. You need to get some kind of documentation together. Well, GWizard Editor can help you with that by reverse engineering a lot of different information from that G-code. So that's pretty cool. That was Tool Crib. Last thing, if you ever need to back up your preferences, the files will show you where to go find them. Where your software is installed, yada yada. That can be handy. About is going to tell you basically, usual sort of information. What's your screen resolution, how much memory is being used. I'm on a special lifetime account here. Otherwise, it would tell me how many days are left on the GWizard subscription. Okay, that is setup. Do I have any setup questions before I go back and actually show you the more fun things that GWizard can do? If anybody has a question, just let me know. I can come back to this as well if we need to. But otherwise, I'm gonna move on from setup. All right, so it's going to save whatever went on there, and I'm back into the main GWizard editor screen. Now let's kind of just go through this a little bit and see what's going on. So first thing to note is as I click on a line of G-code, I get a little white cone. I have a green and a red. This shows me the starting position of the G-code and the ending position. The white is showing me, though, where is the line of code that I'm selecting. You know, where is that? So I can kind of keep up with what's what here. As I select lines of code, I also get these hints. Remember, we talked about how hints are an English translation of what the G-code's going to do. So this line 18, it's got an N number 150. It's a G01Z minus 0.06. And it's saying, well, N150, that's the blocker sequence number. We're going to do linear interpolation, which, by the way, that didn't sound like English. What that means is move in a straight line at feed speed to XYZ. XYZ being this set of endpoints is the final destination in this program. And by the way, it took us 15.8 seconds to get to this spot in the code to execute. All right, so that in a nutshell is what a hint is all about. Let's go and have a look at the hint tab, because here we just see the hint for the line we're currently on. Right, here's a tool select. Here's the actual tool change, and G43 says we're going to apply tool length compensation for the H, which is tool offset 0. Blah blah blah. Like I said, it's a lot easier to read the English than to memorize what all these G codes do. But if we go to hints, we can see this information for every line in our program, which is really handy to be able to do that. Right, and if I double click on the hint, it takes me back out to whatever G code line I was on. So you can go seamlessly back and forth with the hints. Let's see. We got an error tab. Before we mess with the error tab, let's actually create an error. So here I'm on a line that's going to set a feed rate. This is kind of interesting. Not everybody knows this. Anybody that's worked with G-code much knows it, but G-code doesn't just execute left to right. It has a certain precedence, and we're showing you what that precedence looks like here. So the first thing it's going to do is select a feed rate of 7. Then it's going to, which was like the second thing. Then the M3 spindle on clockwise is the next thing it's going to do. Mist coolant on. Then the last thing it's going to do is the first thing on the line, which is it's going to go to 1600 RPM. So that's what this hint means. Now let's create an error. Let's just take that away and make it a comment. Now suddenly we've marked a line with an error. Okay, and we can either see the error with the pop-up tooltip, or we can click over here, and sure enough, I mentioned this before, what it's telling us is you're trying to do a feed, but the spindle is not yet spinning. So, that's going to break your tool pretty fast if you don't get the spindle going. And you can see all the errors in the program on the error tab. You can choose to ignore some of these errors if you wish to, either ignore until the next time you load the file if you're kind of just trying to get through it. Or you can just say, I don't ever want to see this error. I don't care that my spindle isn't spinning. I turn it on manually on my machine. It's not under G-code control. So I prefer to just ignore it. Okay. That's the hint tab. Tools tab. This will show you a couple of interesting things. So it'll show you just the list of tools that are being used. And let me just open this up a little bit more so we can see more about what's going on. I have the ability to change what color I want to plot that particular tool in. And just a note about the colors here. So red is rapids. And so by default, all the tools are set to be green. But you can change it to make things stand out. I mean, maybe you want one tool to be blue or something instead of green. You get to see how long was this tool in use in seconds, how much distance did the tool travel in the cut. That's helpful for figuring out tool life information. And so this is what was the comment near the tool, because that may help you identify what kind of tool it was. In this case, it does. So that's your tool list. And I can hit this Gen Crib button and generate a tool crib, especially for this program to help me manage what's going on. The other thing I can look at is my tool changes. Where in the program do I change the tool? Because, for example, this is a very simple program, but in a complicated program, I may go back and forth with the same tool over and over again and want to see the different tool changes. So that's a capability. On the macro panel, it's really similar to the tool panel. In this case, I don't have a program with any subprograms, but if I did, this list would tell me all the subprograms that are in use within this particular program and all of the macro pound variables that are in use. So this is what I meant by reverse engineering. It can really help you to understand everything that's going on in a G-code program that you're not familiar with. Last one is what we call the info tab. These are kind of like your overall statistics about the program. I've got 764 lines of code, 22K bytes. These are the travels that I use. It's 11 by 4 inches. In X and Y, I use a total of a little over 1/4 of an inch. The alarm feature is kind of interesting. So this was suggested to me by a customer who had a CNC router, and he likes to set up his router to where the spoil board starts at 0. And he said, Bob, can you give me an alarm so that if I go, any more than let's leave a little bit of a safety margin, 0.4 into the spoil board, I want an alarm for that because that's telling me I'm going to have a crash. You might have a 4th axis set up that's, you don't want to go too far left or right depending on which axis it's aligned with, or you might run your tool right into your 4th axis. So that's a really useful feature to have there to help you flag potential problems. Here's your extents with feed motion. These extents up here are rapids as well, and of course, the feeds are traveling a little bit smaller envelope. By the way, I can flash up a bounding box here if I go to my backplot menu and show you the extents. I can show you what this looks like graphically. I can see the range of feeds and speeds that I dial up, the average, my run time. Where's my time being used? Well, most of it is happening. 17 minutes worth is in the cut, and only 12.5 seconds has to do with rapids. That's why a lot of times, you'll hear that, well, you know what, having a machine with rapids 5 times faster isn't going to save you that much. It wouldn't on this program anyway. Some statistics on the types of G-codes that are being used and whether or not you got any errors. How many XYZ moves, arc moves, IJK arcs, radius arcs, feed rate changes, yada, yada. That's all there. And then this is just a little information for me. As I mentioned, this is an unreleased version, and I track a little bit of debugging information for my own purposes. So that is the info tab. And so across all these different tabs, you can learn a lot about what your G-code is doing. Does anybody have any questions about the tabs? The next thing I'm going to demonstrate is the different editing functions that are available for you. Okay, let's jump into what's available on the editing functions. So I'm just going to kind of run through the menus really quickly. I'll show you some of them. I'll talk about others. You have the ability to compare files. Maybe you made a new version of a G-code file and you need to go back and see, well, what exactly did I change? That's easy to do. If I go over here to the edit menu, find and replace and jump, they're also on the toolbar. If you click find, One of the things we did is, I don't know how many of you have ever used programs where you go to find and replace, and the darn find and replace is sitting right on top of what you need to see. So we did this as a toolbar so that there's no way it could block what you're trying to see, which is cool. So I've got this toolbar. I can find and replace. I can also do what we call jumping, and this is sort of G-code specialized. I may want to go to a particular line. I may want to go through every line that has an error just by clicking next and give me a way to take a look at what the errors are doing. I can go to a particular block or end number. I can go to the next tool change. So that's what the jump function is all about. Let's talk about these insert buttons, because the hint is helping you to read G-code. The insert functions are there to help you to write your G-code. So for example, I might click on G-code, and there's keyboard shortcuts here to make this really fast if you don't want to take your hands off the keys and use the mouse. But for example, I don't know about you guys, but a lot of times I forget exactly what a can cycle does. So I come over here to my can cycles. I picked out the list here, and I want a high-speed drilling can cycle. It's going to do some peck drilling, short retract, and I hit insert. And now it's going to tell me just exactly, well, you're going to have an R word, and what that does is your retract distance, a Q word for your peck depth, and an L word to repeat. Yeah, that's pretty handy. You don't have to remember what all those words are in order to use that can cycle. Or here's another nifty one. I can insert a tool change, and I can go, well, I want to choose the tool from my crib. And, click here, and you get to see all the different tools in your crib. So if you've got your crib set up to match what's in your tool changer, this just makes it really easy. You don't have to remember what's going on to go ahead and plug that in, and it'll add a comment that's telling you the exact tool and all of that good stuff. It's pretty handy. So we go through G codes, M codes, feeds and speeds. This feeds and speeds will reflect the G code calculator to help you figure your feeds and speeds if you're a legal user of G code calculator. Your pound variables, G. Who remembers which ones are which and what they do? Well, it's all right here if you need help, figuring out, oh gosh, which ones correspond to the work offsets. Well, G, I can find the X, Y, and Z for G54 right here. I need pound 5221 to do that, and so if I just double click this, it'll insert it. Customs. These are, I call them custom cycles, or the word I like kind of better is code snippets. So, these are things you want to just record. This is your library of your own personal little blocks of code. I get to the end of a program, and I always want to have these blocks of code. So I created an end of program snippet, or at the very top of the G code, I always want to put a project name, and I was the guy that did the G code, and here's the date I did it on. Park the mill, let's raise the spindle and move the table all the way forward so it's easy to reach inside the enclosure and get at my mill table. So this is how you create code snippets that you may want to use over and over again in your different G code programs, and we give you a set of them to start from. Last but not least, and I'm going to go into this in more detail, are our conversational CNC wizards. So these are all different wizards that help you enter the G code, so you don't have to write it all by hand. I mean, it's easy to do that too in the editor if you know what you're writing, but these can save on the old memory and get things powered in there more quickly. Any questions about inserting G code? Okay, the next thing I am going to do is look at what we call G-code revisions. So a G-code revision, imagine if you had a G-code expert programmer on your staff and you could just ask him to do some things for you on your G-code software. That's what a revision does. It revises the software. And so if I bring down Tools Revise, or if I hit the revision button, these are all the different kinds of things that you can do with a G-code revision. You know, maybe you've got an older machine and controller that's got very little memory and you need to squeeze all the spaces out of the program. Well, you can do that with the add or delete spaces revision. You know, maybe you want to adjust one of the words. Maybe you want to, you know, add, I don't know, an offset or something, or scale by multiplying to all of your X words. Maybe you want to, maybe you have a turning program and you'd like to convert a program that's in radius format to diameter. Well, you know, that's pretty easy to do. So that's useful. You know, you can add block skips. Here, let's just do one. This is an arc adjust. I want to change all IJK format arcs to use an R, and I can select either the entire program or just, you know, whatever blocks I have selected, and I apply that. And then let's see, where's there an arc? All right, so here's an arc. This was an IJK. Now it's set up to be a radius format. All right, and you can see the program still is producing the same backplot result. So that's what revisions are all about. And over time, we have a lot of ideas for nifty revisions that'll help you kind of do some major formatting on your G-code. I think the next thing I want to do is demonstrate the simulator debugger. That's this block of buttons right here. And it's really useful if you want to go through and debug a program. So what I'm going to do is I'm going to turn on single block, right? I'm going to rewind the program, and now we're kind of set up in what we call debugger mode, and you can kind of see we're stepping along here. Where the blue is, I get information here just like what's on the front panel of your CNC machine, so I know the XYZ coordinate, the time so far, you know, what's the spindle and the feed rate doing. I got my hint down here to help remind me what the heck that G-code's going to do. And then I got basically the modal information about what's happening. We're in G00, G64, G17 is the plane that's selected, XY. We're in inches mode. We're in absolute mode, so on and so forth. And I can just, you know, click this green, basically cycle start, just like your panel, over and over. Now, you know, I'm tired of trying to get to where you're interested in seeing in your program. So we also have the ability to move ahead, you know, more blocks at a time. I'm going to go 5 blocks at a time, let's say. Or I may want to go until I get to the next G00. Right? So we're on the G00. Here's an interesting one. I can move ahead to the next dwell. Now, why in the world would you ever do that? And the answer is, it's really easy to stick a dwell into a program you're debugging and use that as a marker for where you'd like to go to over and over again. Because the dwell doesn't really change an awful lot in a program while you're simulating it. It doesn't change the backplot at all. So dwell is just a handy way to do that. I can go to the next tool change. That's a good way to move through a lot of programs. Or I can go to actually the next subprogram or go to. So these are your buttons that help you move around the program more quickly. Now I can also turn off the single block and just start it going, and it'll just, you know, it'll just chug along here. And I've got a variable speed here. I've got it set pretty slow so you can see what's going on, but you know, this is what our simulator debugger does to help you find what's going on, and you can kind of see the status of the program as it's executing. Anybody have any questions about the simulator debugger? Cool. So that's a really handy capability, and I stopped it, which kicks me back out of the debugger and repaints the whole thing. Let's see. Not too many other things to demo here. I've got different views. I can see the top, the front, the right. I like perspective. I can manipulate this guy. I just hold down the right mouse button to do that, or I can use these different buttons here to do that. I can, spin the mouse wheel to zoom it, and I can zoom extents as well. Somebody's asking me whether I can load a machine model for fixture interference. Not yet. It's on our list to be able to load STL models so you can see what's going on. It's also on our list to be able to do a full 3D simulation, and we'll do that probably before we load the machine models. In fact, I've already started work on the 3D simulation, so that should be pretty cool. Other questions about the debugger? Cool. Well, I got one more thing I want to demo here, so be thinking about if you have any other questions. But I want to just do a quick demonstration of our conversational CNC wizards, which are pretty cool. So the idea behind the conversational CNC wizards is, I first got the thought that we needed to do these because so many manual machinists will say, oh, gee, I could do this so much faster on a manual machine because I don't have to go through the process of creating a CAD drawing and running that through CAM software and yada, yada, yada. And you know what? That's very true, but obviously they're limited in what they can do on that manual machine compared to the CNC. So I thought, well, gee, what are common things that you'd like to do? Maybe you use them for creating a fixture or whatnot, and that would sort of turn your CNC into a super duper manual machine that does stuff that would be hard to do on the manual. And so we have a set of these CAD CAM wizards, and they're not all done yet. I haven't done the engrave, for example. It's grayed out. I can't click on it. But we've done a number of them. And so what I want to do is show you the whole wizard just to start, give you an idea. So whole wizard looks like this. It wants to know, what's the safe Z? That's the Z where I can go at full rapids through X and Y, and I'm saying, well, I want to make that an inch above the material top. What's the rapid to Z? Meaning when I get to the XY position, I'm willing to rapid straight down. I can do that because I'm not close to the vice jaw or whatever. So how close to the material can I get? And that's 0.2 inches. Then I need to decide, what's the position of my hole. It could be, well, right wherever we are right now, or it could be, I want to enter a grid of coordinates that are arbitrary. It could be, oh, gee, I want to do a bolt circle, an arc of holes, a rectangular grid of holes, or holes in some arbitrary line that's perhaps at some angle of degrees. So I have a lot of options here to decide exactly what I want to do. And so let's just come along here and let's say I want to insert a hole at 0, 0. Let's just put it at part 0. Well, let's see. I'm going to make this a 3-inch diameter hole, and I'm going to put it at 1/2-inch depth. And then the question is, well, okay, how do you want to make that hole? Do you want to use one of the CAN cycles? If so, we'll, figure out these things and how to create the G code. Custom cycles are pretty cool. These are custom deep hole cycles. Many of you will know that drilling a hole that is many diameters deep requires a gentle touch, and so this is sort of your ultimate CAN cycle G-code generator for really deep holes, and it lets you do things like basically what this is saying is from 0 to 3 diameters deep, we're just going to go straight down, and then from about 3 to 5.8, we're just going to do a little chip breaking peck. That means we're just going to pull out just a little bit in order to break the chip. And then for the rest of this hole, if we go more, we might program it to go, hey, we need a full retract or whatever's going on there. So, and we can reduce the feed and speed on each peck, and we can even save the recipes we find if we find one we like. For this demo, though, let's do an interpolated hole. And what that means is, you know, you guys are familiar, we're going to take an end mill and run it in a helix to create the hole. And so given that it's a really big hole, it's 3 inches and a ½ inch deep, you know, I'm not going to stick a 3-inch diameter twist drill in this thing. I'm gonna interpolate that hole. So, you know, let's get some feeds and speeds going. I'm going to run 2,000 RPM. I'm going to run a feed rate of 25. I'm going to use a ½ inch end mill. I'm going to ramp the helix at 5 degrees. You know, I'm gonna go ahead and do the whole ½ inch depth in one step, less a 5/1000 finish allowance. This is how my step out from the center of the hole, you'll see when we do the back plot, is going to go. I can change the feeds and speeds for the spiral. I'm not going to bother. I can decide to climb our conventional. I'm not going to bother. If I care about a really accurate interpolated hole, a lot of times it's a good idea to do the finish both clockwise and counterclockwise because it averages out the errors. Again, I'm not going to bother with that here. Or I can also choose a different finish feeds and speeds. But I'm just going to go ahead and insert it. And you can see here's the code we generated in it. It's going to tell me all the different data that I entered in case I need to go back and figure out, you know, what the heck did I do to create this G code. It comments itself to make it easier to understand. And so the first thing we're going to do is we're going to helix down. So we come down here and we helix down into the bottom of this ½ inch hole. And so that's what this little block of code does. And then we're going to spiral out, right? Here's the spiral out. And then we're going to do the finish code here. We do our full circle in one direction, and that's the end of the whole wizard. And so you have these wizards to let you go through and generate G code really quickly and easily on a quick and dirty sort of a basis, so you don't have to go back through CAD CAM to do it. That, I think, concludes our demonstration. Does anybody have any questions for me at the end here? It's a lot of stuff here, I know, and I hope you're able to get all of that. I did turn on the recording, and so I'll have to watch it and see if it came out, but assuming it did, I will put that up on the same webinar page. You can always find the webinars off the help menu. They're listed there, and I'll also do a blog announcement of webinars. I'm kind of geared up to do one every Friday. Okay. Any questions? If not, I will go ahead and start shutting down the webinar. I thank you all very much for attending. Looks like we used up pretty much the whole hour. There's a lot going on here. Thanks, folks. Oh, good. I got a question. Does the back plot show the machine can cycles? Yes, it does. Absolutely. It'll. In fact, we had some of that going on with our rear panel engraved. There's some drilling cycles here that it shows you. It's a little bit hard to see, but there's a drilling cycle on these holes out here on the corners that's reflected. Other questions? Anything else? Okay, thanks very much. I appreciate your coming, and hopefully we'll catch you on another webinar in a week or two. Take care. Bye-bye.